All right, example number 2. Again, read the question carefully. Think about what is being asked. Then make sure you understand the question. Find the dimensions. Find the dimensions of the box that will yield the maximum volume. Okay, so a little bit different scenario here. We're just looking at a piece of rectangular cardboard. And we have to cut out what? Identical squares from each corner. We know the length of the cardboard piece of cardboard is 15 and the width is 8. So I'm going to again draw a little picture here. So here's my picture. Not the best artist ever, but this is supposed to be a rectangle. We know our width is 8 and our length is 15. Okay. So it's 8 going all the way up and all the way down. And then from left to right, it would be 15. And then we're cutting away squares. We're cutting away squares. So that's going to look maybe something like this. 4 equal squares. So kind of imagine, if you had a pair of scissors and you cut 4 square corners out of this thing, then you could fold up the piece of paper. You could fold up those flaps and create what? And create an open box, okay? So we don't have any idea how far we're cutting in though, but we know they're squares, so these side lengths are going to be the same. Since we don't know how far we're cutting, that's kind of the basic premise of the question, we're going to just use x to define that unknown. Now we do know this. We do know this. If the overall width is 8, and we're cutting away an x from here to here, and another x distance from there to there, we're cutting away 2 x's, this distance would be 8 minus 2x. The distance from here to here would be 8 minus 2x. Okay? And then furthermore, the distance from what? If we cut away an x there and an x there, we're taking those 2 x's away from 15. We know that this distance is 15 minus 2x, all right? The distance inside from there to there is 15 minus 2x. That is very significant that you understand that. All right, so let's begin to come up with our function. Now, we know volume is equal to what? Volume is equal to length times width times height, okay? Width times length times height. All right, so the width is going to be what? The width is going to be 8 minus 2x. The height of our open box is going to be not 15, but 15 minus 2x. And what's our height? Well, if you cut away x and you're folding that up, the height would be what? It'd be x. Okay. Now, this is our volume function. It's not simplified, but this is our volume function. We should be able to come up with the domain of this thing. How do you do that? Set each factor equal to 0, and then do what? Well, I'll tell you. The minimum most x value is going to be 0. That's our definitive starting point. Now, if you let this one be equal to 0, you get 4. If you let this one be equal to 0, you get what? You get 7.5. You have to use the lesser value here, because it doesn't make any sense. If you picked a value like 5, for example, you're going to get a negative value here for the overall width. So you can't use anything greater than 4. So you're going to start with 0, and then you look at setting each of the remaining factors equal to 0, and put in the smaller of the 2x values. So the smaller of 2x values would be 4. There's your domain. That's where we're looking to determine the maximum volume from x equaling 0 to x equaling 4. All right, let's rewrite this now so we can differentiate it, okay? So I'm going to move the x to the front, and then I'm going to FOIL these two binomials together. And if I do that correctly, I get 120 minus 46x plus what? Plus 4x squared. Okay? And now I'm going to distribute the x through. So I get what? I get 120x, all right, minus 46x squared and then plus 4x cubed. All right, so there's your volume function. Again, based on this domain, closed interval 0 to 4. Okay, next step, same as it's always been. The hard part's over, I hope. Come up with the derivative of this function. The derivative, v prime of x, would be equal to what? 120 minus 92x plus 12x squared. Okay, now let the first derivative be equal to 0 and solve for x. I'm going to first recognize that there is a GCF here of 4. And so I have 4. Then you know what I'm going to do? I don't like this written in ascending order, so I'm going to flip it and write it in descending order with respect to the degree of x. So 4 times what? 4 times 3x squared would give me 12x squared. And then 4 times what? Negative 23x. 4 times negative 23x would give me negative 92x. And then 4 times what would give me 120. 4 times 30 would give me 120. All right, you're going to divide both sides by 4, which means the 4 gets canceled out. You now have this trinomial to factor. It is factorable, thank goodness. It is, and if it wasn't, you could use the quadratic formula. You may have to use the quadratic formula in some of these questions. There's a lot going on in section 10.5, all right? Okay, so what is the factorization? Well, I'm getting, let's see, this has to be a 6 because there's a 30. They both have to be negative because there's a negative 23 there. This has to be a 5. All right, so there's the factorization. And I'm getting what? I'm getting x equals 5/3. And I'm also getting x equals 6. Well, here's the reason why we came up with our domain. The only possible value here, x, all right, the only possible critical number here that will work has to be within this domain. It has to be on this domain here, okay? Is 6 in the domain? No. So it's extraneous, not relevant. 5/3 is. 5/3 is. All right, so let's take a look. We're going to have our table here. We have x. We have the volume as a function of x. Then we have our absolute column, okay? And we're just looking for absolute maximum in this case, right? Okay, still seeing everything? All right. So what do? We put our first value here where we begin our interval, 0. That's a 0. Then we put any critical numbers that exist from least to greatest. Only one here, 5/3. And then we put it in 4. All right. So if you were to plug in a 0 or a 4 into the volume function, you're going to get 0. That's fine. That's fine. That's going to happen every time. If you plug in 5/3, you're going to get, I don't know, plug in 5/3 to the original volume, you're going to get about, what, 90.7 inches cubed. Okay, that's all we need to know. We need to know that this value is greater than the other two values, okay, with respect to v of x or y. So now we're able to come up with our concluding statement. So therefore, remember to answer the question or questions that are being asked. So therefore, the dimensions, right? Find the dimensions. Therefore, the dimensions will be what? Well, x is 5/3 inches by what? All right, so this is the height. I'm not going in the order, length times width times height. I'm going out of order, but x is 5/3. So 5/3 is going to be one of our dimensions. It's the height. What about the length? What about the length? We can do that next. Just replace this 2 that represents the length, or it's not the 2. Excuse me. Replace the x here with 5/3 to come up with the length from there to there. So if x is 5/3, plug it in. You get 15 minus 10/3. 15 minus 10/3 is what? It's 35/3 inches. Use your calculator. Now replace this x for our width, okay? The width of our open box is going to be 8 minus 2 times 5/3. So you get 8 minus 10/3. 8 minus 10/3 is 14/3. And these are all inches, okay? These quotes represent the unit inches. So finished with number 2. Hope you're having fun.